900 tons of solid concrete, hanging in the air over a valley 200 meters deep. One beam, one machine holding it. And if a single hydraulic line fails, there is nothing below it but the drop. This is the SLJ 900, the machine China built to do what cranes cannot. They call it the Iron Monster, and the way it works is far more terrifying than it looks. To understand why this machine exists, you have to understand the problem it was built to solve. China decided to lace its mountains with high-speed rail, thousands of kilometers of track that cannot bend, cannot climb, and cannot wait. Where the ground drops away into a gorge, the track simply continues, dead straight, on a bridge. And to build those bridges fast enough, engineers needed to lift entire pre-made spans of concrete and set them between towering piers, hundreds of feet in the air. A normal crane, standing in the valley below, was useless. There was no valley floor to stand on. So the Shijiazhuang Railway Design Institute drew up something else. Built by Beijing Wow Joint Machinery, the SLJ 900/32 is 91 meters long, longer than a football field. It stands 9 meters tall, weighs around 580 tons empty, and it can lift a single box girder weighing up to 900 tons. It does not sit beside the bridge. It drives out onto the bridge it is building, carrying the next piece of that bridge on its own back. And that is the first unnerving thing about it. The Iron Monster works by trusting the very structure it has not finished. Every move it makes while balanced on the edge of a gap. If you find machines like this as unsettling as I do, take 1 second and subscribe. It genuinely helps. Now, let me walk you through exactly what it does, step by step, because this is where it gets tense. It begins far from the bridge, in the casting yard, where the concrete spans are poured and cured. The machine lowers itself over a finished girder, grips it, and lifts all 900 tons clear of the ground. Then, it drives. On 64 wheels, arranged in 4 blocks of 16, it crawls forward at barely 5 kilometers an hour, slower than you walk, carrying its enormous load toward the edge of the last completed span. At the edge, it stops. 2 support legs fold down and plant themselves on the pier ahead, spanning the empty gap. Now the machine is a bridge over the void, holding a bridge in its arms. Slowly, it feeds the girder forward, out over nothing, until the beam hangs directly above the 2 piers where it belongs. Then, with millimeter precision, it lowers 900 tons of concrete into place. One wrong calculation of weight, one gust of wind against that enormous side profile, and the whole system is fighting physics it cannot win. Machines like this are not forgiving. Around the world, launching gantries have failed, spans have dropped, girders have twisted off their supports, and workers have died when a lift went wrong. The SLJ 900 carries a load heavier than a fully loaded jumbo jet out on a cantilever over a drop that offers no second chances. Everything depends on the beam being seated, the legs being planted, and the load being balanced before the machine ever commits its weight to the gap. So how does it not simply topple forward? The answer is in those rotating wheel blocks and that long body. Each of the 4 wheel sections can turn 90 degrees, letting the machine shuffle sideways to pick up a beam and then straighten out to drive. Its length spreads the weight backward, keeping its center of mass over solid, finished deck, even as its nose reaches out over the emptiness. It is, in effect, always counterbalancing itself against the thing it just built. Once a span is set, the monster backs up, collects its legs, drives back to the yard, and does it all again, pier after pier, valley after valley. What used to take months of scaffolding and cranes now takes days. It is one of the quiet reasons China has been able to throw high-speed rail across terrain that most countries would simply call impossible. The Iron Monster is not elegant. It is a 500-ton machine that solves a deadly problem by becoming part of the danger itself, walking out over the drop again and again, so that a train can one day cross it without ever knowing the valley was there. And that is the strange genius of it. The most dangerous machine on the bridge is the one that makes the bridge safe. Because in the end, the machines we build to conquer the impossible are only ever as safe as the people who understand them.